question 6.1.6, we are at the end of our paper, and this is, we'll try and do this one on the question paper because this is again just an analysis of our graph, trying to analyze what we see, and from there answering these questions. It's going to be one of those inequality questions again. This time it's similar to these questions, but not quite. Okay, so let's see how these work. Okay, so we're not really asking here for which values of x does the parabola lie above the straight line, vice versa. It's more of a higher level question basically. So let's see, what are they asking us? Write down the possible values of k if the graph of f of x equals negative 3x squared plus 12 minus k does not cut or touch the x-axis. Okay, so now let's just quickly break this down. First of all, the graph they're talking about here, f, is our parabola that they gave us. And if you remember, we worked out that our parabola has this function, right? It's negative 3x squared plus 12. Now the negative k, or the minus k part, has now been added because it plays a role here. It serves a purpose. In other words, if k is a certain value, or if it's a range of certain values, it will influence what this graph does or where it lies. Okay, let's see what this means. For which values of k does our parabola not cut or touch the x-axis? What does that mean? Not cut or touch. So if my parabola, at the moment my parabola is cutting my x-axis at A and B. Okay, so if I don't want it to cut my x-axis or even touch it, it needs to be dragged down. In other words, if I take this graph and I pull it down so that it turns here, or here, or here, or anywhere below this point over here, which is x equal to 0. You'll agree with me that if my graph turns anywhere just below 0, then my parabola will not touch, or it will not cut the x-axis because it never reaches the x-axis. Okay, so that is, they want to know for what values of k will that be the case. In other words, for what values of k will my parabola be dragged down all the way to a point just below 0, and in such a way that it of course will never touch the x-axis. Okay, so what does that mean? How do I interpret this? If my graph does that, if my parabola does this, right, in other words, if it doesn't even touch my x-axis, it means it doesn't go all the way up to 0. In other words, it doesn't go to x equal to 0 or even y equal to 0. So that means my turning point, okay, it's all about the turning point here, because that's what so at the moment my turning point is 12, right? So for my current parabola, the k value is 0, because if I take this away, then I have this parabola. But as soon as I add any numbers, as soon as k becomes something other than 0, then this value over here is either going to drag down or move the parabola up, right? So if you can see this as, if you think of this in terms of a standard form, I've got a x squared plus q. And q is going to be all of this, right? So the ax squared part is here, and my q part is all of this. Now q will be equal to 12 if k is 0, right? Like we said earlier, then I have this graph that they gave me. But for my parabola to never even touch my x-axis, my q value must be less than 0. Remember, it mustn't even be 0, because if it's 0, it's going to touch the x-axis, and I don't want to touch it. I want it to lie below. In other words, it must never touch and it must never cross it. So that means my q value must be less than 0. If that's the case, then I will have the graph that they want, meaning does not cut or touch. So for this to be true, my Q must be less than 0. Now, like if we look at this equation they gave us here, my Q value is this whole part here, 12 minus K. So in other words, my Q must be less than 0. I hope that you are able to see this, because from here now, if I just remember, we want to know for what values of K, and values of K is important because we're not looking for a particular single value of K, we're looking for a range of values of K. So if I go and I solve this inequality, I will have 12 here, and if I take K over, so K must be greater than 12, and that's my solution. And how does this work? If K greater than 12 means any number bigger than 12 will make this true. Let's see and test it. If K is 13, which is greater than 12, 12 minus 13 gives me -1. And if Q is -1, I will have a parabola that looks like this. Let's quickly write it here. -3x squared. 12 minus 13 is -1, so it will be -1. So that means my Q value will be -1. In other words, let's say if -1 is here, my parabola will now turn at -1, meaning it will never cut or touch the x-axis. So that's true. And if you follow that on, you'll know that that means if K is 13, 14, 15, 16, this number will always be a negative number, meaning this thing will just drop. It will drop further down and down and down, meaning it will never touch the x-axis, nor will it cut the x-axis. So the solution for A is K greater than 12. Okay, that's it. K greater than 12, meaning every value greater than 12, that will make, or that will satisfy this answer over here, this condition. Right, let's go to B. So again, for which possible values of K will the graph cut the x-axis in two distinct points? So in two distinct points means, like it is now, this parabola is cutting the x-axis in point A and point B, so it's cutting it at two distinct points. The only time where it will not cut in two distinct points is if it only touches the x-axis, meaning it touches it once, it doesn't cut in 2 points, and that is of course when my K value or my Q value is 0. In other words, if my turning point is 0, in other words, if this whole thing, if Q is 0, then it will only touch the x-axis. But we want to know for which values of K for which values of K will this graph cut the x-axis in two distinct points. So for that to be true, my Q value needs to be positive, right? Remember, in the previous question, my Q value was negative, and that resulted in this parabola not even getting to the x-axis, right? So if my Q value is positive, if my Q value is 0, it touches the x-axis once, but we don't want that. We want it to cut in two distinct points. So that means my Q value, in other words, this point here, the turning point, it must be above the x-axis. In other words, it must be positive. So Q must be positive in order for us to get this correct. So we know that Q is represented by this whole part over here. So to answer our question, so Q must be greater than 0. That means my 12 minus K must be greater than 0. That means K must be less than 12. Okay. How does this work? K less than 12. If I substitute K less than 12 in there, any number less than 12, like 11. So 12 minus 11 gives me 1. So that will then become -3x squared plus 1. And plus 1, of course, lies above the x-axis, meaning my graph will turn there. It will cut in two distinct points. And if I choose any number, of course, 1, 2, 3, going all the way up, my graph will cut in two distinct points. So in other words, K less than 12, if K is less than 12, this part here, the Q part, will always give us a positive answer, and that will then result in our parabola turning above the x-axis and cutting our x-axis in two distinct points.